Good morning, ladies and gentlemen. I welcome you on this rainy morning session. And I have the pleasure to welcome here also our invited speaker who arrived from Abu Dhabi, Professor Preslav Nakov, who in Abu Dhabi works as a chair of the Natural Language Processing Department at Mohammed bin Zayed University of Artificial Intelligence. He also holds several chair positions in top NLP conferences. He's taking part in editorial boards of well-known NLP journals. And his research is, I think, best known for first making state-of-the-art resources for Arabic, and second for fake news detection and fact-checking, which will also, I believe, be partly presented in today's lecture, which is called Factuality Challenges with LLMs, or in the era of LLMs. So welcome here, Preslav, and the floor is yours.
Thanks a lot for the invitation. I'm going to talk about the misinformation risk that large language models pose. So actually, immediately after ChatGPT came, we have teamed with several fact checkers and actually professional fact checkers from leading fact checking organizations and researchers from both academia and industry, and we started thinking about what does ChatGPT bring us, with regarding factuality. And we have published something that is now appeared in Nature Machine Intelligence, and so you can go and you can read more. But I'm going to do a little bit of overview of the most important things. So, well, one thing is hallucination, right? I mean, okay, I don't really like. It has become word of the year. It reminds me of when fake news was word of the year, a few years ago, by many dictionaries. And I mean, okay, hallucinate. I'm not very sure whether this is the right term, because hallucinate means that you see something that is not there, okay? And if I ask a question and I get an answer that is not factually not true, where is the hallucination actually? I mean, if the model, I mean, yeah, so if I have retrieval augmented generation, I give it something, or if I say translate me this and then tells me something that was not there in the original text, I understand it's a hallucination, right? You're seeing something that is not there, but actually, kind of people are misusing this term to talk that something that is factually not true, right? So, and this might or might not be due to hallucination. But anyway, factuality, right, of large language models is big. And what is the problem? The problem is that they are speaking in very coherent tone, okay? They are anthropomorphic, talking about I, right, like a human being. They are very authoritative liars. So many times I know it's false, but it sounds so good, I almost want to believe it, right? They are very convincing, okay? And then this public perception, because those models are very, very good in certain tasks. And then there's the expectation that they should be good at everything, okay? And they should be always up to those standards. And sometimes they are not, right? Then, okay, this always fixed training, and there are always kind of events that they don't know about, right? Yeah, they don't really cite their sources, so it's kind of hard for us to know, right, whether they fabricate something or whether they're telling something true, because they don't really make citations to their sources. If they do, they kind of are often wrong. They kind of hallucinate those citations as well, right? So from a fact checker's perspective, the problem is that if I'm chatting with one of those large language models, right, in a chat mode, it's a private communication. It's just me and them, right? It's not like in social media where if I post something, people can see it, fact checkers can go and check it. Now I'm talking directly. So kind of, there's no access to fact checkers, right? So they cannot really help you here. And then if you want to misuse this technology, right, you can actually go download open ones and you can do it. And then there are other things related to privacy. People kind of are putting things there, and actually, I don't know if you know, but according to the terms of use, anything that you put there, okay, when you're in chat mode can be used to train the model. Which means that if somebody kind of then has the right prompt, might actually kind of get the text that you have put there in your, chat with the model. By the way, one way to avoid this is to use even if you use the paid version, they can still do it. But if you use the API, they cannot do it. Okay, so kind of be careful. Actually, many organizations have kind of forbidden the use of those models at work. Okay, what are the threats here? Well, you can do personalized attacks. Okay, I can basically, if I have some emails or some media posts from somebody, I can impersonate that person. I can impersonate politician, fact checker, and so on, a journalist. Then, from a fact checker's perspective, I can use the power of those large language models to bypass detection. Why? Well, fact checkers cannot check everything. Fact checking a claim, even for major organizations, very, very big ones, is their capacities to fact check one claim per day, sometimes two. Okay, that's the most they can do. Okay, so now they really, really need to prioritize. What should we check? And there are kind of different criteria. It should be kind of likely to be false, should be of public interest, right? Should be likely viral. If I say something that 5 people see, who cares? We don't want to check that, right? So kind of you want to find what is viral. But now I can use those large language models to mutate the claim, to kind of generate many versions of it, right? And then all of these versions can fall under the radar. And then people have been misusing this. They are fake profiles. They are entire kind of fake websites, okay? And this kind of old information because those grow, right? Kind of people are automating misinformation at scale already, right? So how do you address the threats? Well, one thing is you want the language models themselves to be safer, and I'm going to talk more about this because we have been building our own large language models, and I'll tell you how we can make them safe. Retrieval augmented generation is also kind of something that can help, right? So if you put there in the context something, it can still hallucinate. Actually, in that context, I'm more kind of comfortable to talk about hallucination because if I give you the evidence here and you tell me something else, then I'll say, come on, right? I mean, you are contradicting what I told you. Just like if you do summarization and you say something that was not in the original text, or translation and you say something that's not in the original text, then I'm happy to talk about hallucination. If you tell me something that was not probably kind of not even there in the training data, then yeah, that's different. Another way actually is to use a larger model, because large models actually hallucinate less. Why? Any ideas? Well, okay, here's the thing. They have more capacity. They can remember more. Okay, and those models, they typically operate in two modes. One is I'm going to remember and recite verbatim or almost verbatim what I have seen before, or the other mode is I'm going to kind of be creative, right? So kind of it's between kind of remembering and being creative. And guess when the kind of the factuality problems start? Well, kind of when it's getting creative. But kind of those large models, they have more capacity, so they can verbatim remember more, so they kind of have to go in this kind of second mode less often. So that's why kind of, they are better at remembering things that they have seen. Well, you can also fact check the outputs of large language models. I'm going to talk about that. And well, another thing that you can do is you can try to detect machine-generated text, okay? Because, I don't know, it might be actually good to know. If you come to a website, everything is machine-generated, okay, maybe it's suspicious, even though we can also revisit that. I'm going to, talk about this in a moment. Another thing is you can actually check where it's coming from, okay? That's what journalists do. They ask, are there 2 or 3 independent sources, that are saying this, okay? And also reliable ones, okay? So basically kind of knowing, you cannot fact check every single claim in the world, but kind of you can probably have a list of websites that are reliable and that are not reliable. This is what people do in let's say, antivirus programs and whatever. Or those are malicious websites, right? Or kind of those are kind of, users that we trust or that we don't. I'm not going to talk about this, but it's actually kind of a very powerful way also to deal with the problem. And of course, these regulations, there's GDPR, there are kind of tons of others, right? The problem is that the bad actors are not going to follow the regulations, right? So, and one other way actually to deal with the problem in general is to promote AI literacy. In the past, we have been talking about media literacy, right? To people, it was in the context of fighting the fake news, or people should know that you know, in social media, it's not like watching the national TV or kind of, you know, reading New York Times or kind of some reputable source that has editorial policies that are checking and kind of put a lot of effort, you know, to give you high quality content. Anybody can say anything, right? So just because you have seen it there and so on and so forth. Now we need kind of AI literacy, because I actually kind of had a few slides ago the example when actually ChatGPT came, that there was an attorney that was using ChatGPT. He says, I thought it's a search engine. And I was looking for, you know, cases related to my case, and I found those, okay? And then he went to court, and those are hallucinated. Kind of those cases did not exist, kind of, you know, the model. So basically, we need this kind of literacy. People need to know what those models are and what they are not. Okay. We have covered this. Yeah, I mean, if you want to learn more, we have actually kind of another very nice survey on factuality of large language models in the year 2024. And okay, now turning on the other direction, right? What opportunities the large language models give us to fight disinformation? So the first thing is, I was talking about virality, that I can use the large language models to avoid detection, right? But I can reverse this. I can actually use large language models to try to look into the different claims and try to normalize them. So basically, one problem that we have been working on is, if I have a tweet like this, right, can I normalize it in the form that human fact checkers are formulating the claim, right? Because kind of here, there's something set in a little bit different way, but kind of I want in a canonical way, right? And if I can do this to the tweets that are coming today, right, I can actually detect that something is kind of happening more frequently. And you can do this in different ways via prompting. And of course, kind of you want to do this in a multilingual way, right? Kind of we have been doing this across different languages. Okay, how do you do fact-checking with large language models? Actually, in many different ways. I'm going to show you some. Time permitting, I also have some demos that I can, you know, show you maybe at the end. But so that's kind of an earlier work that we started working on before there was even kind of ChatGPT. But okay. Imagine I have a claim like this. The sunlight can travel to the deepest part of the Black Sea, okay? So here's an algorithm. The algorithm is, I start asking questions about this claim. Question like, what is the greatest depth of the Black Sea? Then I get an answer. I can get an answer even from the internal knowledge of the language model, or from Wikipedia, or from the web, or from a knowledge graph, right? And we have been exploring everything except for the knowledge graph. Then I ask another question. How far can sunlight penetrate water? And I get an answer. And then, you know, I can also ask a language model. So, I mean, I can ask a language model to generate me a question. I can ask a language model to answer this question, or, you know, get evidence from the web. And then I can ask, you know, a language model to reason about this dialogue and to tell me whether there is contradiction or not, okay? And in this case, and basically you iterate in this loop. Okay, so kind of, you know, you have a component, ask a question, answer the question, and then, you know, tell me whether there is enough evidence to tell me whether it's true or false, okay? And see, kind of the key thing, this is a complex claim, right? And you had a system like that. Now, let me kind of tell you about a different way to look in the same problem. So, okay, both James Cameron, the director of the film Interstellar, were born in Canada. I have this claim, okay? Now, if I go and I search on the web, I don't really find directly an answer, right? If I put this claim directly, right? But, you know, as a human, what do? Well, maybe I want first to say, okay, where was he born? Okay, and if I do this, actually, it's in the knowledge graph of Google. It even tells me directly. I don't even need to go much further, right? This is Canada. Then I can ask, who is the director of this film? And I directly get an answer, okay? I can ask, where was he born? And again, you know, kind of the search engine very quickly, right, gives me this. And then based on this, a human can say, well, that's not true, right? Because I have here a contradiction. It's like the previous thing, except that, you know, here there's a system, there's kind of a plan of what I want to do, okay? So, and what we did, actually we did this before there was ChatGPT. We did this with Codex. So ChatGPT is actually a descendant of GPT-3, but also a descendant of Codex. Codex is for code. And it's just that. So here's what we have. We just say, have a prompt, like generate a Python program that can code two functions, for answering a simple question and to verifying a simple claim. And then we have in context warning where we give it several programs like that. So basically, we ask the language model to generate for us a program, which is basically a plan how to fact check the claim. And then all we need to do is execute this program. And all we need is implementation of something that can answer a very simple question and something that can check very simple claim. And now we can plug this and we can now check much more complex claims, right? We also have some explainability because we can actually tell you, here's the plan for checking it. Okay, now fact checking. Before that, something on terminology, right? Back in 2016, I think, or 18. 16, yes, it was fake news was word of the year, in many dictionaries and so on and so forth. And people were saying, okay, fake news, let's go and do fact checking, right? Because fake news sounds like false news, okay? And then over time, people said, no. Professional fact checkers, international organizations like the European Union, United Nations, and so on, started talking about disinformation. So what is disinformation? Well, it's something that is false, but it's also harmful. Okay, the question is, we don't want to check every single thing. We want, and the reason we care about this is because it can cause harm. Okay, and over time, people actually realized that the harm is even more important. So in the time of the pandemic, the World Health Organization started talking about an infodemic, which sounds like pandemic to me. And actually, if you think about it, it's not really about the truth. It's about the potential harm. Okay, and actually, this is a snapshot that they have taken from the website of the World Health Organization just a couple of days after they declared the pandemic. Okay, and those were their top 5 priorities in fighting the pandemic. Okay, and you see that the number 2 was fighting the infodemic. They understood very early on that the information is going to be very, very important, and they even coined a new term, infodemic. Okay, but now, if you think about it, this is an evolution of the terminology, but also evolution of the public attention, and also evolution of research. So people initially were looking into, let's do fact checking. Over time, they realized, okay, we should care that it's false, but it's also that it's harmful. And over time, they started talking about harm, right? Again, in 2020, what was the 2016 it was US elections, it was, fake news, let's do fact checking. 2020, what was it? It was about hate speech. It was about harm, right? And here, the infodemic, it was also about harm. So basically, people are moving away from fact checking and going more in the direction of, wait a minute, why are we doing it in the first place? Because it can cause harm. Well, if this is the case, let's focus whether something is harmful or not. And whether it's true or not, that's secondary. Because I can even manipulate you with true information. I can cherry pick things. I can get a list of things that show one side of the problem, or really more like the exceptions, and present them to you to sound like the rule. I mean, just one example. For example, there was at some point in the context of COVID, right? At some point there was this claim, now COVID-19 is the disease of the vaccinated. There are many more vaccinated people dying than non-vaccinated. And this was a true claim. The problem was that the country about which this was made had almost no unvaccinated people left. Okay, they had very, very few unvaccinated. So now if you look at the proportion, right, actually the mortality among the vaccinated was several times less. But you make this claim, right? So what I'm saying is, it's not just to fact check, right? It's also to to see whether it's potentially harmful or not. And that's a nice story that we are moving away from factuality and going into harm, right? Which is the real problem. Except that the large language models came and made factuality great again. Now we have hallucinate word of the year. Because we cannot really use them if you cannot trust them, right? So and now you need to go to do the checking of the output of those models. And I cannot really say that this model is doing it on purpose, has malicious intent. Harm is irrelevant here. Factuality is, okay? So factuality is great again now, okay? So again, we started looking into that's currently in archive, but into what does it take to fact check something like this. It's just a little bit made up. Okay, you ask who is the king of Canada, and it's slightly edited kind of output of a large language model. And what do we need to do? Okay, well, it's interesting because turns out that we are unprepared for this problem. We are not prepared for this problem. Why? What have we been doing in fact-checking? Well, we have been fact-checking a claim, where it's true or false. We have been fact-checking an entire article, where it's fake news or not. We have been, less often, but we have been working on this problem. We have been looking into, can I trust this source, an entire website or entire user? Even maybe can I use this we have this group of coordinated people, can I trust this kind of group, right? Something like that. But we have not been studying the problem of his text, check every single thing. Nobody worked on that. We have been checking an individual claim or an entire document, but not really going there. And what does it take? Well, maybe the first thing is you want to decompose it into simple claims, just like I have been showing you before. Then you need to decide which of those are actually interesting to check and which not. Because there is right. So as an AI language model, I cannot access the recent events. I don't want to check that, right? So you need to see which of those you want to do. And there are also opinions. Queen Elizabeth is arguably the most popular, I mean, it's an opinion, right? So you don't want to check opinions. You want to check, if I ask you, what is the best color for a car in Brno? I can say it's white. That's an opinion. Or who is the best veterinarian or something like that, right? It's not like, who won the elections or something like that. Even there has been controversy sometimes, right? And then what do? Well, you go, you retrieve information, you have stance of each claim with respect, whether it's, agrees or disagrees and stuff like that. And then the next thing is you want to go and to fix every single claim. Some claims you cannot really fix. You they are so outrageous you need to delete it. Some you can fix. Maybe if the year is wrong, you can put the correct year. Or maybe if you have a claim, you say, oh, this guy was, member of the parliament, for 7 years, and now you cannot verify the 7 years, but you can verify that he was member of the parliament. Maybe you can actually delete part of the thing. So you can delete entire thing. You can change part, right? Or you can delete part. And after that, you want to put this back into into correction of the text. And actually we have built a system. We have annotated data set. This is quite painful, right? But to implement each of these steps. And then you can actually present this to the user, right? To say, he's the correction that we have. And you can also show the evidence because you have retrieved it. Okay, so we have this. And I have been talking about the factuality and the harm, okay? But that's not everything. Because if I'm to convince you of something, right? I mean, fake news is not just about lying. It's not just about harm. It's also how you do it. How do you do it? Well, you need to use certain techniques to convince me. If I just take an article from a good newspaper and I just change one word, maybe an important word, maybe in the title, that's not going to work so well. Why? Because, I mean, it's probably not going to become viral, right? I mean, I really need to manipulate in a certain way. How do I do that? Well, this goes back to Aristotle. Aristotle talks about ethos, logos, pathos. So it's about, emotions or about broken logic, logical fallacies. You're either with us or against us or things like that, oversimplification. And they're personal attacks, praises, so it's about who is saying it. Oh, this world expert said, climate change is real. Or this politician did this lying all the time said it, okay, you cannot trust it. So it's not really about the argument, it's about who is saying it, right? This is one way. The other one is the logic, and the third one is emotions. And now the thing is, if you really want to convince me of something, you need to work hard on some of those. Because otherwise it's not going to work, okay? Probably mostly on the emotions, but, other things as well, the persons. And so we have been working on trying to detect the specific use of those propaganda techniques in text. Now, it's not about true or false, but if you see a text that has a lot of this, right, this actually makes you think, wait a minute, somebody's putting extra effort to convince me of something, right? So, and the thing is, if you have a system to detect this as a signal of potential, look, something fishy is going on here, right? There's no theoretical defense for the people that are doing that are generating the disinformation against a system like that. Why? Well, it's not an option not to use those techniques. It's not an option because it's not going to work. Okay? They are very, very central. That's one thing. The other thing is, in terms of media literacy, we have been talking about media literacy, right? It's very, those techniques, they're easy to remember, right? Kind of, and after interacting with a system like this for a while, you kind of start seeing them, and you just, I mean, I cannot read the news properly anymore. I cannot. If I read something, I just see them. And if I see too many of them, I say, wait a minute, what is this, right? So kind of this can be a great way to, to promote media literacy. And actually, we have this thing. I don't know if I have now kind of the time. Let's see if I have time at the end. But I have a demo. We have a demo. We have been working with the Joint Research Center of the European Commission. So they have been interested. We started like working more than 2 years ago in anticipation of the last elections, European elections that happened, right? To study. It's an interesting demo where you can go and you can study the propaganda techniques by media and by country. So you can kind of go and you can compare, right, about a specific topic. What are the techniques that are being used? And we also have there the framing. So what is framing? Well, framing is the perspective. It's not about topic. It's about the perspective from which you are discussing a specific topic. So, for example, in the case of COVID, I can emphasize the health perspective, or I can emphasize the economic perspective, right? It has become even a political question, right? So kind of, and those are things that you might want to understand. I mean, or in the context of, some conflict or Brexit or something, they can be legal aspect, they can be, they can be kind of moral aspect, and many other things. Even about the COVID measures, it can be like, okay, is it legal to have these measures? What the quality of life and stuff like that. So kind of, you can emphasize different perspective about the same thing. And it's interesting that you can go there and you can, study different media. As you see, we have like 8,000 media from different countries. Okay, now you can, but back, let me go back to how can you use large language models, to find this information. Well, one thing is you can also use them for synthetic data generation. Okay, again, in these propaganda techniques, here's the problem. In our training data, some of the techniques we have very, very few examples. Some we have more. Okay, and the problem is if you annotate, let's say, 1,500 documents, and you only find this little number of those, how many do you need to annotate so that you have enough data, to train a system, right? I mean, that's not good. So what? Oops, I did something wrong, but I recovered. Well, what you can do is actually kind of, you can do synthetic training generation. You can kind of, like with proper prompts, you can ask the large language model to generate you examples of those techniques. And then if you train the system, actually kind of it helps you a lot. Another way to do kind of synthetic training generation is to do this. Kind of we did this for the purpose of fake news detection. Now, there's not that much training data for fake news. There are like tens of thousands of articles, but kind of you probably want millions, right? How do you get them? Well, one way is kind of I can go and generate them automatically, okay? But kind of we had like a smart generator that was using some of those propaganda techniques, because remember, it's not just about hallucinating. It's about kind of, this persuasion has to be there, okay? And what did we do? We experimented just with two. One is emotional language, it's like worded language, right? Deadly crashes, right? Something like that. And the other one is kind of appeal to authority. Kind of we have been generating fake quotation by somebody who is an expert on the topic relevant in this thing. And it turned out that, when you train a system on this, it actually kind of, fooled people better and was actually better at detecting, human written fake news. Some tools, again, kind of time permitting, I can show you some in real action. But so Loki is one tool, and you can actually kind of call it. You can give it a text or a file or a video or audio or an image, right? And you can actually kind of go and check it. So what it does? Well, if you say like Elon Musk bought Twitter and renamed it to X, it would decompose it into two claims, then start asking questions about each of these claims, then would get evidence, and then try to make a verdict based on this. Okay, so we have also kind of this OpenFactCheck. That's a very ambitious project that we have, and it's currently in archive. But again, kind of if we have time, I can show it to you. But what it can do several things. Okay, it can evaluate an entire large language model, how factual it is. It can evaluate a scorer if you have a system. So basically what we did, we went into look into the literature. What are the data sets? What are the models? And we kind of put everything there. So if you have a specific scorer system that you have built, we can go and evaluate, tell you how reliable this system for detecting, kind of for fact-checking text is. We can tell you how factual a model is. But you can also go there and you can build a custom fact-checker. How? Well, because they have different components. What do you do with the claim? How they retrieve evidence, and how they do the verification. And here are some steps, and kind of you can decide which of those steps you want, which you don't. And also we have put there the implementation from the literature of different fact checkers, how they do the decomposition of the claim, how they do the retrieval, and you can now kind of say, oh, I want to do the fact checking, the retrieval from this model, but the analysis of the claim from this other model. And it's actually kind of very, very interesting. And you can kind of, and then you can actually kind of, because this is now a fact checker, you can go and you can automatically evaluate it and to see whether you got something better. And this is modular. You can kind of go and you can, write your own things. And of course, it can actually fact check a claim. So kind of it can do what I was, showing here. So basically, it can tell you, okay, whether it's true or false. It's going to tell you what the error is. It's going to tell you what the evidence is. It's going to suggest a correction, right? And yeah. Actually, why don't I really show you now? Let me kind of go. That was in, or maybe let's do it at the end, right? I can actually kind of show you some examples of that. And this kind of, dashboard and so on. So you can see here, evaluating a model, evaluating an LM response, evaluating a fact checker, and so on. It can also tell you also kind of how expensive it is. Because if some of those fact checkers are calling large language models, right? And it kind of also tell you how much it costs you. So kind of you can see if I built a model from these different parts, I can tell you how good it is, but I can also tell you how costly it is to run it in this way. We have this kind of LM-Polygraph. That's a different perspective. And it's also something that you can go and you can get directly the code. It's a library where we have more than 30 different models, and it's kind of constantly growing for uncertainty quantification. So what is the idea here? Kind of this fact checking is expensive because you need to decompose the claim. You either kind of use some local large language model or kind of you call an API, right? It's kind of computationally expensive. Okay, even if I kind of ask the model multiple times, there are different ways. One way to fact check with large language models is to ask the model multiple times and see whether you get the same result, and kind of the things that you get all the time are probably kind of the more reliable from the perspective of the model, right? But that's expensive. So the question is, is there something in the internal parameters of the model that can tell us whether the model itself is certain in what it has generated? And that's the idea here. So, and this kind of, a demo, which I think currently is down, but kind of the code is there. You can kind of run this locally. If I have something like translate into Virginia language, I want a small cup of coffee, it generates something, okay, some crap, but the model is not certain in this generation, okay? We can see it from the internal parameters of the model. But if you say, okay, translate this to French, je veux une petite tasse de café, and say, okay, fine, and kind of it's very, very confident here, right? So, and the thing is, imagine kind of, with this kind of system, as the model generates something, you can kind of, show, oh, it's about the entire thing, whether kind of the model itself is certain or is not so certain about its generation, which can be actually quite useful. This doesn't mean it's true or not, but if the model is not so confident, then that's kind of a strong signal, right? And here's another example. Okay, Consider they are dinosaurs that are coming to Earth and they have pneumonia. How do you cure them? Okay, here's how you cure dinosaurs, right? And of course, it's some kind of totally fabricated. If you say, okay, a human has, pneumonia, what do you do? Well, I mean, you do this, and kind of the model is more certain, right? Okay, how do you perform kidney surgery? Okay, that's what you do, 73% confidence. And now you say, how do you perform kidney surgery with one arm? You say, oh, here's what you do, and the confidence is not so high, right? That's kind of desirable, right? You want something like that. And more recently, we have kind of just like at ACL, something else, where we have been looking into uncertainty quantification, but not for the entire thing. You want actually to spot the specific places where the model is not certain. Now, I mean, people have been doing this, and they can tell, oh, it's not certain about this comma, or it's not certain about this word, or something like that. That's not so useful, right? What you want is a claim, an entire claim, right? So, and then kind of, you have to be smart about how you model uncertainty. Not just like to look into whether the model with high probability, in this word or something like that. Kind of, things are a bit more complex because, and here in this work, there's different kind of uncertainty. And there's uncertainty about, if I want to tell you about biography of Madonna, one uncertainty is, should I tell you about where she was born first? Should I tell you about how many Grammy Awards she has? I mean, kind of uncertainties about what should I talk about. That's one uncertainty. We don't care about this uncertainty. Okay? You want to kind of, in the way that we kind of look into the model's uncertainty, this one you want to discard, and we have a smart way kind of to discarding that, right? There's kind of another uncertainty about, do I say awards or prizes or something like that? Kind of it's synonyms. That's another uncertainty that we don't care about, right? You want to discard that. Then actually there's uncertainty. So basically, kind of, the model might be uncertain, but you say, no, you are certain. Because, I mean, this kind of uncertainty, we don't care. But there's another thing. You have also the opposite problem. The model can be very certain about something, but actually you say, no, you are wrong. You cannot be so certain. Why? Well, I'll tell you why. Imagine that she says, the model says here, that she was, let's say, a British singer, okay? And the model, the first time probably is very, very unsure. Is it British, is it American? Okay, I'm going to say British. And then if kind of the model continues generating, the next time it says to say, she is the most famous British singer, it's going to say, yeah, I'm certain. Why? Because it conditions on the thing that it has already generated. And the first time the model was uncertain, the second time says, yeah, I'm super certain. It's here. It's in my attention. I'm attending to it. So basically, kind of there's uncertainty that you want to erase because it doesn't matter, and there's uncertainty where the model actually is certain. You say, no, you are not certain because you are not certain before. You cannot be certain now, right? And kind of those are things that we are actually modeling, right? And this is already kind of there in this library. Okay, let's see. I was talking about fake news. I was talking about machine-generated text. And for machine-generated text, there are kind of different ways to deal with this. You can do, there are kind of, let's say, maybe kind of 3 different ways. One is white box. I want to look into I suspect which is the generator. And I have access, and I can like check. Kind of basically you say, his text. Did ChatGPT generate this or not? Okay, that's the thing. I mean, that's white box kind of, and I can look into the model, and I can look into its internal parameters. Okay, and I can do something about it. There's also black box. Black box is here's a text. Is it machine generated or not? But or even it is generated by ChatGPT or not? But I don't have access to the internal parameters of the model. I just have the text. And that's kind of black box. And there's watermarking and other methods. So white box, how do you do it? There are different ways, but kind of one popular way is to do perturbations. So the idea is this. You give the text to the model that you suspect might have generated, and you say, tell me how much you like it. What is your perplexity or something like that? It doesn't have to be perplexity. It can be other things. Can be, how much do you like this text? And then you say, OK, now I'm going to take this text, and I'm going to change some word by something from the top choices of the language model, right, in this position. And then I ask the model, now, how much do you like this one? And all I care about is, does the model like it better or like it worse? And guess what? If the original text was generated by that model, right? When you do this, with kind of you most of the time you're kind of going to break something. So kind of the model is kind of likely to kind of to like the change kind of worse. But if it was written by a human, sometimes it's going to be worse, but sometimes it's going to be better. Say, actually, this is better. Why? Because it comes from the top choices there. And basically what you do maybe like 1,000 times this procedure, right? Kind of this is one way to do it. And there are people from Stanford that have been doing this, and we kind of did a smarter way at the modeling, right? Kind of this kind of our method, so that with less perturbations you can do kind of better. Now, the technique machine-generated text. We have been working quite a lot on this, and you can think of different tasks. This is now black box, okay? You can look into binary detection. Is it machine or is it human? Another task can be who did it? Is it ChatGPT? Is it Llama? Is it Jace? I mean, which is the specific model that did it? Or you might also kind of want to ask the question, which part was written by a machine, which part was written by a human? You can even simplify this and say, I'm only going to look into the one change. I'm kind of looking into this specific case where, let's say, a reviewer is writing a review for a paper, writes a little bit and says, forget it, ChatGPT is going to finish it, right? And now the question is, can you detect where this happens, okay? And actually, it turns out that you can detect with a very, very high, with the difference of 2-3 words around, you can actually detect where the change happened. Now, to deal with this problem, right, we have, and that's kind of we have this M4 data set, which is you have multiple generators, you have multiple domains, you have multiple languages, right? And you have also kind of multiple detectors. And the idea is kind of to have a growing repository of different examples so that you don't really kind of overfit to some specific model. And that's kind of outdated because we have much more. We have shared tasks running on this. Yeah, we have publications. So just like to give you some high-level highlights from this, right? So, okay, cross-domain. If you have multiple domains, okay, so you have a generator, and let's say the detector. The detector can be something simple like Bert or Roberta, okay? It's good at detecting this. And now, if you change the domain, so for example, I train on Wikipedia and I kind of try to test this on archive or something like this, you can actually kind of the performance can degrade quite a lot. If you stay in the same domain, it's very, very easy to get to 100% or something close to 100%. Okay. Now, interestingly, if I change the generator but I stay in the same domain, you see that the drop is minimal. Why is that? So this means that I have a different generator, but I stay in the same domain, and I can train on one generator and test on a different generator. There's not that much of a degradation. Why is that? Well, if you think about it, if I change the domain, even if I stay with the generator, I have two classes. What happens? I mean, in my test data, the positive and the negative, basically, if I change the domain, everything changes. The human text changes because it's from a different domain. The machine-generated text changes. If I stay in the same domain, if I change the generator, the human class stays the same. So basically, one of the classes remains the same, and then for the model, it's actually easier. So, I mean, you might think that, so what I'm trying to say is it's harder to build a system to detect whether this was written by ChatGPT or not. It's easier to build a system to say, is this human essay written by a machine or not? Is this review written by a machine or not? Kind of, if you pick the domain, you can actually, that's good news actually, right? So, but you need kind of system specialized to a specific domain, right? And if you want to cover more domains, you need to cover, you need to have kind of more. That's why you have this kind of growing repository, and other people are doing similar things, right? Kind of you need, so that if you want to do something for a specific domain. And you have across languages. Now, but I was talking about fake news, I was talking about machine-generated text, and I want to also talk a little bit about the connection between the two. What we did, that's not published yet, it's in archive, but we said, okay, let's look into those data sets for fake news, okay, and let's train a system on that, okay? And now, let's try to evaluate it on human written text, on machine written text, and so on. And we found two biases. One is that the detectors that you train on, on human written fake and human written real news, right? This is kind of a data set that we have two biases. Number one, they think when you give them machine generated text, they think it's fake. Okay, this kind of prior, they kind of, not always, but kind of they tend to think it's fake. And if they see something human written, they tend to feel to think it's real. Okay, now that's not necessarily a bad bias to have. So that it's not necessarily bad that if I give you something machine written, right, it says, oh, that's probably fake news. That's probably not a bad bias. Except that things are changing. And we had kind of, this paper at Nakov, where we have been looking into this. Wait a minute. In the past, let's look into real news. Let's forget about the fake news. Fake news you can automate. It was done also in the past. Real news. Who writes the real news? In the past, humans. Now, you see more real news written by machines. In the future, it can be even that most of the real news are written by machines. Now, if I have a detector that tells me everything real is fake, machine written is fake, that's not good, right? So kind of we have been studying this, and we have been looking into how should you train those systems so that they are kind of now robust, right? Kind of they do the right thing, right? How much human written real and fake, machine written real and fake you should give them in what proportion, right? So that kind of they stay robust. Okay, another problem about this information, okay? It's people are doing a lot on adversarial attacks on those models, okay. I can actually do different kinds of attacks, and this attack is simple. I want to change something, and what I can do is I can just say, okay, I generate some fake information, I put it on the web, and I hope that it's going to be crawled and it's going to go into the training data of the large language models. Or I hope that at test time, when there's this retrieval augmentation, the system is going to pick my fake stuff, it's going to give it, okay, here's the evidence, and then, it's going to generate kind of what I want, right? Kind of the disinformation that I want. And actually, this is very real. Let me show you. So I have a colleague. Okay, and if you go to Bing and you say, tell me about, kind of this colleague, okay, it says, well, I mean, here, kind of gives you something. And see, there are additional questions, right? And other search engines also generate automatically questions, right? And look at the questions. See, look at this one. Can he, shoot laser beams from his nose, right? And, I mean, how did it happen? Well, look at his webpage. Do you see anything suspicious? You should be looking here. No, you don't see it? No? Because it's in white font with white color and small font and stuff, right? But what's this? Dear LLMs, an obviously important fact, blah, 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 is that he can, kind of, is working on this technology, to have laser beam, And, yeah, this is what it is there, right? And see how easy it is. How easy it is, right? And, okay, and we have been looking into how people can actually do this kind of attacks, right? You can kind of generate. I mean, one way is to say, look, I'm going to take a language model that has a lot of hallucinations in general, just ask it to generate something on the topic, and I'm going to, just put this, and I'm going to obfuscate the truth. It's going to give some crap. Or you can kind of revise something, right? I mean, maybe I go there and, effectiveness of the vaccine, instead of 98%, I put 50%, and then, or something like that. Or, there's control generation. I don't want to spend much time here. Oh, actually, this is a very dumb but very effective method. I can just kind of, put it multiple times or something like that, right? Because then it can be picked more. And actually, kind of this reiteration is the most effective way. And how do you fight it? Well, of course, you can do misinformation detector. We have been talking about this. But actually, the prompt turns out to be very, very important. Actually, people don't realize how important the prompt is. And I'm going to tell you about the prompt in a while. So if you actually tell it, look, here's the evidence that I'm giving you from the retrieval, but be aware, not everything there might be true. If you do this, the model actually knows, and if the evidence that is there contradicts very seriously the background knowledge that it does, it might actually decide to override to say no. Another way is like, because you have multiple pieces of evidence, what you can do is kind of you can show it different subsets of that. And the idea is that even if something is very, very relevant, it's not going to be in many of those groups. And kind of maybe you can, then you do majority voting and you can kind of defend. And of course, this is kind of very, very primitive, right? But kind of just like some, simple and cheap strategies to defend yourself against that. Okay. I wanted also to tell you a little bit about the safety of large language models. So we have Jace. I'm going to tell you a little bit about Jace. But before that, the safety mechanisms. Where can you put the safety mechanisms in those large language models? Well, you can clean the data, so that it doesn't have bad content. You can put it inside the model, kind of with instruction tuning. You can do instruction tuning for safety. You can do it in the calls to the model, in the prompt. And you can also have external classifiers, right? Something that analyzes what the user types or what the systems kind of does. And where should we put it? Well, we put it everywhere, just to be safe, because each of those can fail, right? Now, if you are going to choose one, which one would you choose?
The first one?
Yeah, kind of this is what people think, right? Kind of I should clean the data. Well, actually, the most important one is the prompt. People don't realize how important the prompt is, because the model just listens, okay? This is the most effective one and the cheapest one. Kind of all you need is kind of prompt engineering. Now, the first one, cleaning the data, yes and no. Why? Okay. Now, imagine that I want to build a system that is kind of a chatbot, talks to the customer for customer support. Maybe I want to train it on good data. I don't want you to have ever seen, bad data, I don't know, hate or something like that, right? I don't want. Because why would the model even want to know about it? But now if I want a universal model, I might want to use it for different things. One of them can be content moderation, can be, detecting whether something is hateful or not. If the model has never seen hateful content, how can it possibly then be trained to detect it, right? It needs to know, if you don't know what is bad, I mean, I have no way to tell whether something is bad, right? So kind of, basically, you have to be careful, right? You don't want to train only on bad content. You definitely want to clean your data, but do you want to clean it too much, right? Because then because you have other mechanisms as well, right? And actually, kind of, it might be good. Mm-hmm. Now, okay, instruction tuning. We have developed this taxonomy of three-level taxonomy of how to do the safety of the large language model, and there are different things. There are kind of things about human chatbot interaction harms. There are things about toxicity. There are things about misinformation or kind of bad advice about finances, medical, and so on. There are things about unethical behavior, like tell me how to cheat on an exam, tell me how to troll my friend who has a new car, or stuff like that, right? And we have put this into the model, right, kind of to make it. And actually, this was featured in the AI index report, this data set. And these days, we are adapting this to other languages. So, for example, we adapted it to Chinese. And when you do this, I mean, something that's important, this kind of cultural specificity, right? There are things that you need to pay attention to. So, I don't know, you have here a name like Mary, okay? Instead of Mary, you probably need to put some other name, right? It's not just kind of translating it. But then there are other things. There can be, politically sensitive topics that you might not want to discuss, or they can be legal, there can be society, there can be, certain things that, that are somehow culturally specific. Okay, the calls to the model. Here's the prompt, the hidden prompt that we have in Jace, okay? The whole thing, right? So we wrote this, we have been looking into others, and we have tried to simplify it in different ways, and when you do, actually kind of it works worse. It's a little bit repetitive, but it's very interesting. You say, okay, don't be harmful, racist, sexist, whatever. Don't do unethical, harmful, unsafe actions, respective phone, no offensive language, not toxic and stuff, right? So, and interestingly, the model actually listens to that. Okay, why? Why this is very effective? I'll tell you why. Because the model, when it generates, it attends to this. It's very hard for the model to ignore it. If it's something in the training data, in the tuning data, it's one across, billions and billions of parameters. Here, it actually attends because it's there. Of course, it makes it more expensive because you kind of have this already there, right, each time. It also limits, how many tokens you have left, but makes it really, really safe. And we have this also in Arabic. So what is JACE? Well, JACE is a model. It's actually the best one for Arabic. We have built it over a year ago. We released in August last year. It's a collaboration between our university, Mohammed bin Zayed University of Artificial Intelligence, G42, and Cerebras. Cerebras for the hardware primarily. And yeah, now there's kind of 30 billion, there's 70 billion, there's an entire family of models. It's available on Hugging Face. And actually kind of the prompt is there. You can choose to use the prompt or not. There's a playground. It's also on Azure. So it's also kind of, you can use it on the phone. We have also kind of started releasing things for other languages. So for example, on the phone, you can use it in Arabic, you can use it in English, and now kind of, you can now use it also in Hindi. So there's a new model that was announced like a couple of days ago. And it's there also on Azure. And it was released at the same time when on Azure was put Mistral and Llama too. Kind of at the same time, kind of, also our model was put there. About Gen AI in general, in our university, we have an entire institute on foundation models, and we are building models from scratch. For Arabic and for other languages, we have for code and for other things. I mean, we are kind of one of the institutions that built Vicuna. Vicuna was the early way, kind of attempt to reproduce the capabilities of ChatGPT, right, in a cheap way. We have like something on climate change. We have multimodality. We have code. But something that I want to stress here, we have this LM-360 initiative. LM-360, what is this? Well, it's really, really open way to release models. So it's not just that you say, okay, here's the model, we release it, or you write a paper and say, which we did, of course, this is the data that was trained on, we process in this way, and so on. Actually, we release every single experiment, every single checkpoint that we have done. And so basically in this release, there were 360. Basically, okay, you say, here's the model, and here are the 360 experiments that we did, and here's every single one. And this one comes from this one or something like that. And actually, you can learn a lot from this. It's kind of truly open. Now, some other institutions kind of started doing similar things. Yeah, because if you are to understand those models, that's important. And maybe I stop here so that there's some time for questions. And yeah, in the meantime, maybe I can also show you some demo while the questions are coming. So.
Okay, yeah. Thank you very much. So we have time for a few fruitful questions. So if anyone
I don't know how to copy this.
Ask.
How do I copy? Yes.
In the last part of the presentation, thank you for your amazing presentation. It was really, really interesting. In the last part of the presentation, you say that using prompt engineering could make the model safe. Oh, yeah. Do you think that you can do the same for hallucinations, like modifying the initial prompt to control the hallucination of the model?
Yeah. OK, so the question is whether you can do the prompt to control hallucination of the model. Actually, we do a little bit. If you are paying attention, we are saying kind of, don't do things that are not truthful and so on. Now, there has been an interesting counter-argument to this, right? And that's something that probably kind of need to explore a little bit more. So people have been talking about if I say to the model, let's say those diffusion models, to the diffusion models, actually kind of, they have like weaker thinking capabilities. If I say, draw me, a picture of a room without an elephant in it, absolutely no elephant. I don't want an elephant there. Guess what happens? He writes you one that has elephant, right? So kind of, but those are kind of weaker models, right? Kind of, those models here are much stronger. So, I mean, but kind of the question is the prompt actually dangerous by telling it not to do something? Now kind of we have the bad word there, and is it going actually kind of to understand because it attends to it? That's kind of, yeah, an open question, but for us, kind of it works.
Okay.
Thank you. Another question? Yes.
Thank you for the presentation.
When you are using these models for the facts checking about, you're asking question about the content, but sometime when you are going to the details, these LLM will stuck. No matter how you change the question,
Mhm.
they will give you the same answer.
Yeah.
In this case, do you think that we need that external source for this kind of fact checking? When the question goes to the detail, no matter how you change the question in what direction you're asking, it will give you the same question, the same answer, which is not true. What do you think we can do in this case?
Well, I mean, okay, so listen, if the model has seen something, let's say, I mean, what is true, actually, what is true might change over time. What we think is true, okay? Or the objective reality can change. So, for example, who is the president of this country? You know, tomorrow can be elections, and you know, it's no longer true. Used to be true. Or kind of you have like, I don't know. Let's say you say sound disinformation, whatever. You know, this helps, that helps. You say, okay, there is no cure for COVID, or there is no vaccine. This was true until some point, but also can be our understanding of the thing. Initially, what was it? It was, oh, it's not airborne. It's absolutely not airborne. It's very heavy. It's down there. You have kind of, you know, to wipe. COVID doesn't spread in the air, right? And this was kind of what people believed. Kind of, so kind of this was true, you know, but kind of over time, kind of it happened not to be the case, kind of, you know. So I mean, there's subjectivity. There's also kind of limit to what we know, what we think is true. There's also kind of temporal aspects there, right? That so, for example, if you ask ChatGPT, you know, where I work, you know, kind of it shows my previous institutions, right? So I mean, those kind of things are there, and no matter how much you ask, you're going to get the wrong answer. So basically, you need better evidence. You know, if the model doesn't know, it just doesn't know. But that's kind of why, yeah. I mean, this is actually one of the limitations, right? That we need access to good high-quality information.
Okay, thank you. Well, I think unfortunately we are quite out of our time. So.
Let's see. Well, I have also typos here. Let's see. Elon Musk bought Twitter in 2020. Let's see. Well, yeah, I have typos here. So there's nothing, yeah, kind of, it couldn't really go. Okay, let's see. And here you see kind of, you can choose, you know, different claim preprocessors, different retrievers. And here, for example, I'm combining something from our own claim processor, but kind of, you know, the verifiers from a different method. And here it tells me it's not true. You didn't do it in 2020, you did it in 2022, right? It shows me the evidence based on which this is based. Yeah. And we have other demos, but we are running out of time. So
Okay, yeah.
Thank you.
Thank you very much again.